Hiya, it's Rob Value. I've got this awesome thing. It goes up your nose, you trim your hairs with it. Shut up, listen, okay? What I want to talk to you about today is abstract systems, okay? And you know, how I view them. So we've got the real world around us that we assume is real. And you know, we can interact with it physically and so on. But then you've got ideas, you know, imaginary concepts, and they don't exist in the same way. You know, you can think they exist abstractly somewhere. You know, you've got like this field of possibilities of all the things you could ever imagine, and you know, you could say they exist there. They all exist as much as each other. And you know, who knows, maybe they manifest somewhere else as something real. You know, maybe they do, maybe they don't, doesn't really matter. But anyway, so these abstract systems, I can prescribe whatever I want onto these systems. I can just make up a system, and it's my system, and only I get to say what happens in it, and that's it, right? Okay, so I can make up a very, you know, if I make up a very simple system where I say I've got an imaginary arena, and I've got goblins in it, and I've got orcs in it, right? And one of them fights, an orc fights a goblin, and the orc always wins. Okay, that's it. That's my abstract system. Okay, it's as simple as that. So if someone says to you, why have you got orcs in your abstract system? I go, well, because I say so. I don't need any more justification. It's my abstract system. I created it. I have given you the rules about it. That's all you need to know. Why have you got goblins in it? Because I say so. Why do orcs always beat goblins? Because I say so. I don't need any more proof than that. You know, I can use the rules. If you're asking me a more complicated question about my system, I can use the rules of the system to show you why it's true. So, you know, let's make it a little more complicated. Let's also put minotaurs in, okay? And we'll say minotaurs always beat orcs and minotaurs always beat goblins. So that's a little bit more complicated, but, you know, again, why have you got minotaurs in? Because I say so. Why do they always beat it? Because I say so. Don't they ever get tired? No, because I say so. That's not part of it. Being tired isn't part of my abstract system. So one question you can ask is your abstract system internally consistent? And you know, with a fairly simple one like mine, you can test that quite easily. You can put all the different matchups and see, is there any problem? Is there any contradiction? There doesn't seem to be. There's a clear winner no matter who fights who in my little system. But if I change the rules, so if I just go back, I've just got orcs and goblins, and I say orcs always beat goblins and goblins always beat orcs. Okay? So why do orcs always beat goblins? Because I say so. Why do goblins always beat orcs? Because I say so. Alright? But what happens if a goblin fights an orc? They both win, apparently. You know, and that doesn't make sense, does it? You know, unless I allow for, I've made a rule to explain what happens when they both win. There's a problem. It's not internally consistent. Now, it doesn't matter. I can still have that system. It's just that, you know, whatever happens is undefined, or I need to sort it out, or whatever. That's up to me to sort out. It's still my system. You can't just say, well, you can't have it. So the thing is, you prescribe on abstract systems. When you're dealing with reality, on the other hand, so I've got abstract systems over here, reality over here. That's where I like to keep it. With reality, we describe. It's different, okay? We try and say, what can we learn about it? What can we say about it? So we try and model it, but we never get to tell it what it is or how it works. And it could change at any second, you know. You could know everything about reality at a certain point and it could just change. And you'd be like, you know, everything you know about it is wrong all of a sudden. You've got to start again. And I'm not saying that's very likely to happen, but it could happen. What can you do about it? Fuck all. That's what you can do about it. Fuck all. Yeah. So all you can do is your best. You know, you try and come up with a way of modelling it. Now, you use abstract systems all the time to help you deal with reality, and you do it so often that you don't even think that you're doing it. You go from the real world into an abstract system, get a result from that system, and put it back. So these systems can be very useful with regard to reality. They don't have to be. They don't have to be useful. They don't have to make sense. They don't have to do anything. But you know, some of them do. But the thing is, it only works, you know, as far as you know. So I'll give you an example. You know, if you get one orange and you add another orange to it in reality, and we say, well, we'll model that by saying we've got number 1 and then another 1, and we add them together, and then we go into mathematics, which is an abstract system. And in our abstract system, 1 plus 1 equals 2. So in our system, why does 1 plus 1 equal 2? Because we say so. Don't need any more justification than that. We say so. Okay. You know, you can. So there's loads more rules to mathematics, obviously, and it's tested and it's internally consistent. You know, it is. If it isn't, there's a problem and needs to be sorted out. So we say, okay, our answer is 2. We'll go back to reality, and we'll say, you know, are there 2 oranges? So then we count them. There's 2. Yes. Okay, it works. It's the same. So our abstract system mirrors reality in that instance. You know, we can try it again with 2 other things. One of something, one of something. Does it work? Yes. And, you know, it works, obviously, every time anyone's ever tried it, it works. And so people don't even think that they're using an abstract system, but you are actually. But at any time it might not work. You might get 2 oranges, put them together, count them, and then for whatever reason, you've got 3 oranges or whatever. I don't have to describe how, but I'm just saying that could happen. The result from your abstract system could suddenly be wrong. And you can't just say it will never happen, because you don't get to describe, you don't get to prescribe what happens in reality. Okay, reality is, you know, is just telling us what's going on. It's giving us information. We just have to deal with it. So it's the same with everything. We model it. You know, we model gravity. We model everything you like. You know, our models are pretty good, but they're still models. They're still abstract systems. We apply them to reality. Do they work? They seem to work very well. You know, if we find something that doesn't work, we go, there's a problem. We'll go back, work on our abstract systems, apply them again. But you don't get to say about reality because I say so. Because, you know, if in your abstract system you can say, like, everything has a cause. Right, that's fine. Why does everything have a cause? Because I say so. It's my abstract system. I can say whatever the fuck I like. In reality, if you just say everything has a cause, why? Because I say so? No, not because you say so. No, stop it. No, you can't say that about reality. You can say, in my experience, that is the case so far, or it seems that way, fine. But you don't just get to say everything has a cause, period. You can't make any statements about reality that are definitely true. You just can't. It doesn't work that way. Well, you can try and do it, but, you know, it can just be wrong, and it's simple as that. So all you can do is test it to see how right your statement is. So, you know, we've only experienced a very small amount of reality. So if we say, well, it seems like it works that way in that bit, so I'm just going to assume it applies to all of it, and it does because I say so. No. So if you're going to use an abstract system, you need to test it, and you need to test the assumptions you're using. So, you know, if everything has a cause, that's an assumption, and that needs to be demonstrated to be true for everything you're dealing with before you can use that abstract system to actually reliably come up with a result. Because otherwise, if you're just extending it to other things that you don't know if they have a cause or not, you're just guessing. You're just saying, well, they probably have a cause. Like, well, that's not good enough, is it? So, you know, that's the problem with trying to use logical arguments as in place of evidence from reality, is that you're just extending what you think you know, or your observations, your little abstract models of reality, and then you're just saying, well, I'll just expand that. And it's not up to someone else to prove that that's not true. I mean, that's just ridiculous. I mean, we've got no need to. You're just sitting there saying, I've got all these results. It's like, yeah, well, what do they mean? What can you do with them? Nothing. We've got no way of testing them, because, I mean, you're extrapolating into the unknown. You can't even test if your assumptions are right, let alone your conclusions. So that is the difference. You can't just make general statements about reality and just say they're true because I say so. But you can with abstract systems. So the thing is, sometimes people take an abstract system from reality, and then when you talk it through and examine, and it isn't internally consistent, there's a problem with it. And so if they're then going to claim that somehow maps back to reality, you've fallen down before you've even started. If this doesn't even work in theory, how can it possibly work in practice? So if there's logical fallacies within this, things don't add up within this, then you're dealing with a reality that doesn't add up. And if you're going to start saying that, you just say, well, you've thrown all reason and logic out the window, haven't you? All right, well, that's enough from me. Thanks for watching. I've been Rob Bailey. I'll see you next time.